Alright, guys. So, NASA and the government will tell you that there are things called dark matter and dark energy. But the folks in the electric universe community will tell you that there is electricity that NASA is not accounting for. And so they invent notions and ideas such as dark energy and dark matter. Let's see if Dr. Walburn here can clear things up for us. He's from the government.
But we're starting off here with a graph, the only graph I think I have. It looks pretty complicated, but don't worry about it. We're not going to talk about everything that's in here. You can begin by ignoring all the red and blue points. Throw them out. Those are for something else. Then you see these lines drawn on here. These are evolutionary tracks. So that's what the stars do in this diagram when they start to run out of hydrogen fuel and they begin to evolve, as we say. They follow these tracks in the HR diagram, and we now understand a lot of why that is, why they do that. And
Okay, let's hear a little bit more.
well, getting back to our main story here now, these massive stars, they get into trouble when they try to move over here, and they get more luminous, and their winds, the stars, even normal massive stars lose material all the time through stellar winds, but it's a steady quiescent flow, and that's okay. But here then they start to get unstable and they can't hold themselves together. So these stars have developed kind of a last ditch mechanism to extend their lifetimes, if you will, which we still don't understand in detail.
Oh, you don't? Okay. What else you got?
First thing we see is a supernova explosion in distant galaxy. It's too late. You can't go back and see what kind of star did that. You can try to get some information, some inference, and maybe you have some old images of where it was there. But we would like to see one of these stars that we have observed doing all sorts of things explode, and then we would know things that we don't know.
Okay.
R71. And you don't want to believe the plot. That's this little line here. You don't want to believe that too much because it looks like it. Why does it go back?
Because it goes up and it goes back and it goes across every one of them. There's a little retrograde each one.
Oh, this little glitch here?
Yes.
That's the terminal age main sequence, and that's where really the hydrogen burning stops completely. And so, this is a plot of brightness versus temperature. So when stars get to that point, they do a little retrograde, as that's a good word for it, a little glitch.
I guess there's a glitch in the diagram.
Higher resolution and in more detail. And so here are those same stars I just showed you in a higher resolution image. Now what looked like the two brighter stars are actually these two clusters. They weren't single stars, and that's a big problem, even in Very Large Cloud, which is the nearest neighbor. Is this really a single star, or is this two or more stars so close together that we can't resolve them? And so we're always looking for higher resolution to answer that question.
Wow.
And so the years up at the top, about as Julian days, and you can't remember what those mean, but they're useful.
Sounds good.
Down, 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 down. These are points from our previous paper, published in 2008. And so the title of the paper was The End of the 3-Decade Outburst of R127. Before the paper even appeared in press, it went back up again. And that's what they do. We don't understand them. We don't understand why they do this. And now...
Okay, so you don't understand.
That's what it's doing, and unfortunately, I can't explain to you why or how, but there are obviously some instabilities inside. These 8 years, we've observed this star, or this LBV, an outburst, to go from a hotter state to a cooler one, and then back to a hotter one. So that's what we're doing here. I can't tell you why, but first you have to know that it does this, right? If you didn't even know this, you're never going to figure out why. Sometimes we have an argument with theoreticians who don't like all these observational details, but they like to explain things, and it's true. The only way you can explain things is by physics, but you can't explain something you don't know.
Tax dollars at work, baby. Thanks for watching, guys. Have a good day.